Question 14 from exam 1 is the last question on the data analysis topic, and this one is asking about least squares regression, and it asks what would happen if you took the response and explanatory variables and reversed them. Which of the following would not change in value? Well, we don't need any calculation for this. If you understand it, you can answer in about 10 seconds, but let's have a think about it. Would it be the residual values, the predicted values, the correlation coefficient, the slope, or the intercept? Well, I think it's useful to visualize a diagram. Imagine we have two variables, let's call them variable 1 on the x-axis and variable 2 on the y-axis. And what if now we were to switch them? Well, obviously the graph would change. So what does that tell us about these 5 statistics we have listed here? Well, the residuals, remember, are the actual values minus the predicted values. So they're based on the y values. So if the y value changes, the residuals are going to change and the predicted values are also going to change. What about the correlation coefficient? The slope, we can see from that diagram the slope is changing. The intercept would also change. So actually, it is the correlation coefficient. It does not change because that measures the association between two variables. It does not depend on the direction of which one is the explanatory and which one is the response. And remember, correlation does not imply causation. It's not a directional thing. So C was the correct answer for that one. You could also just get out your CAS calculator, plot a very simple data set and actually try it yourself. If you swap the x and y variables and recalculate the r value, you'd find that it won't change. Next, we're going to have a look at part of an extended response question. So in this extended response question, it was about traffic congestion in Melbourne and Sydney. We were given some time series data, and we were also given a sketch of that data. And the question that students found difficult was part B2, where the question asked to determine the average rate of increase in percentage congestion level for Sydney. So what is this actually asking for? Perhaps the wording is a little bit confusing, but actually all it's asking for is the gradient. It's the rate of increase. And so we can read that off our regression line, which we have above here. So the gradient is going to be 1.15. So the average rate of increase is 1.15% per year. Perhaps some of the confusion came from the fact that it's asking for a percentage, but if we look back to the graph that was given on the previous page, congestion level is actually measured in percentage, so the gradient would just be a percentage itself. So that one is just being careful about reading the question and understanding that the gradient is the average rate of increase. This was the last part of that extended response question on traffic congestion, and it was the one that students found the most difficult. Since 2008, the equations of the least squares lines for Sydney and Melbourne have predicted that future traffic congestion levels in Sydney will always exceed future traffic congestion levels in Melbourne. Explain why, quoting the values of appropriate statistics. So we need to look back at the equations that we were given. We were given the regression line for Sydney, and students found the regression line for Melbourne in the previous question. So to explain why Sydney would always exceed Melbourne, if we look at a graph and plot Sydney and Melbourne's regression lines, we can see that the key thing is that Sydney has a larger gradient. So it's going to keep on increasing, and its traffic congestion level is always going to be higher than Melbourne. But when it says quote the values of appropriate statistics, not only do we need to say that Sydney has a larger gradient, but also that it actually starts off higher. So in 2008, Sydney's traffic level is higher, and then because it has a larger gradient, it's always going to be exceeding Melbourne. So we need to put that into a sentence, just making sure we quote the statistics. The two key facts are that it starts at a higher level and has a higher gradient, so it's always going to be above the line of Melbourne. We can see there's quite a lot of information there, which is why students obviously found that question difficult. And it was the last question on the statistics section in 2018. Alright, let's quickly recap the key concepts, and they're really all to do with this concept of interpreting a regression line. The first one was that correlation does not have a direction, so if we swap the x and the y variables, the correlation coefficient is not going to change. The next one was about the gradient, giving the average rate of increase or decrease. So if a question is asking about the average rate, then you're looking for the gradient there. And finally, on this worded question about why one line would always be above one another, and we had to explain that not only did it have a greater slope, but it also had a greater starting value. That's it. See ya.